did I put this?
I bet you do.
I did one at a time. You're supposed to. You're supposed to blink one eye at a time.
Found it. Okay.
Why do people actually do that?
Number 15 and 17, are those no solutions?
That would take a lot longer, though. That's not that hard.
Oh, and I have your
Gavin, are you okay? Can you mount the mount?
Never goes up to that.
Yeah. Who got the water?
I have the question on my list real quick.
I got one too.
Oh my god.
15, 16?
15. 15 and 17. I have the question right here.
15 and 17, no solution? One of them, yes. Not both. So you need to rework 17.
Literally, I'm not even joking, that's what it was. It was chicken nuggets for breakfast. He said 8.
One of those is no solution.
Mr. McClain.
Yes.
So me and Steve walked down the hall, and I was like, what do you think a Crunchwrap is? He was like, it's probably a chicken nugget wrapped in a tortilla. It was literally 2 chicken nuggets wrapped in a tortilla. I'm not even joking.
So you were half right.
Oh, well, I mean, I consider that right.
Well, he was like 3/4 right, because... Or 2/3.
Now look at his point.
All right, guys.
Gravity.
You guys are... Oh,
what was that?
All right, guys. All right, guys. Bring it in. What we're doing today is we're starting off with adding and subtracting matrices. What we're doing today is more matrices, more problems with matrices. Now, the first thing we're going to do is adding or subtracting 2 matrices. For us to be able to add or subtract 2 matrices, the dimensions of the matrices that we're adding or subtracting have to be the same. If they are not the same, if the dimensions, the sum or difference of 2 matrices with different dimensions is undefined. So if the dimensions are not the same, it's undefined. But if they are, we can add or subtract the corresponding elements. So let's look at the first one here. So here, our first matrix that we have is a 2 by 2. The other matrix is also a 2 by 2. So that means we can add them, and we will add the corresponding elements. Now the first element that we have is 2, and we'll add to it its corresponding element, which is 1. Our next one that we have is -1, and we'll add to it its corresponding element, which is 2. Questions on this so far? Then we'll have our next element, 3, added to its corresponding element, which is 4. And lastly, we'll add 0 to its corresponding element, which is -2. Questions on how we set this up? Two plus 1. -1 plus 2. 1. 3 plus 4. 0 plus -2. Questions on this here? Triple A.
I hate that commercial. That was so.
Oh, I hate you.
Really?
No, I'm just kidding.
I've actually never eaten Pittsburgh.
Really?
What?
Me neither.
You're not missing out on anything.
I haven't either.
It's like their chicken breast. Okay. If you guys do a good one, I want to sound upset.
Questions on what we did here?
Nope.
Are you ready for the next one? Now the next problem is different. Well, it's a 3 by 2 and a 3 by 2, but we're not adding, we're subtracting.
Okay, so 2 minus 1.
So we're just doing the same thing we did but subtracting.
Yes. So 2 minus negative 1. Then we can say negative 3 minus 2. Our next one would be 5 minus 7. Then
Does this get any harder today?
They told me that it was easier than
4 minus 8. Then we have negative 2 minus negative 5. And lastly, 8 minus 6. Now we'll go on and simplify. 2 minus negative 1.
3, right?
Negative, negative, make a plus, giving us 3. 5 minus 7. Negative 2. 2 minus negative 5. Well, the negative and negative will make a plus, which would also be 3. Negative 3 minus 2.
negative 5.
Negative 5. 4 minus 8.
Negative 4.
Negative 4 and 8 minus 6.
2.
That's it. Questions on this here?
Oh, we're just. Wait, would it not? Wait, they're not the same. It would be,
So this one would be and then plus 0.
Indefinite. Uh-huh. Undefined.
Because the dimensions are not the same. Now, it would be tempting to want to add 0, 0 in here, but our starting matrix for the second one is a 2 by 2. If we add those, it won't be a 2 by 2 anymore. It'd be a 2 by 3. Mm-hmm. Yeah, because even though 0 doesn't seem like we're adding anything, for matrices we are. Because 0 is still a number, it is still a place in the matrix. In that spot, it's still an element. So adding the zeros would change it. Normally, in linear and other types of math, adding 0 doesn't add anything, but here it does. But this would just be undefined. The dimensions are not the same. Questions on this here? I'm going to go back to the previous one, this here. Yes? We can do these in the calculator. Now, to do the last one in the calculator, not the undefined one. So the first thing we would do is second matrix, go over to edit. We'll put the first matrix in as matrix A. So it is a 3 by 2. So 2, negative 3, 5, 4, negative 2, 8.
Wait, 3 by 2?
So it's 3 down, 2 over. And once we get it typed in, we'll go second quit, second matrix. Over to edit to put the next one in, we'll put it in as B. It is also a 3 by 2. Negative 1, 2, 7.
Are we on the
8.
very first example here?
The second one. Example 1B. So the top of the second page, or top of the back of the.
No, it's a 3 by 2.
So the second one we did.
It's this one. It's the second example.
Mhm.
Yeah. So it's 3, negative 5.
What?
So the second problem that we did, the subtraction. So back of the first page, B.
I started the page, that's why.
Yeah. Okay, so we understand how to get them both typed in, yes?
Now it says syntax error, quit or go to.
Do go to. So we'll define the first one as A, the second one as B, yes?
Yeah.
So in the calculator, first thing we're going to do is, once we have them typed in, we can go second matrix A minus second matrix B.
How did you do that?
So second matrix in the first row, you can recall them. So you select A first. enter, minus, as we're subtracting it, then second matrix, go down 1 to B, hit enter, so you have A minus B, hit enter one more time, and we get 3, -5, -2, -4, 3, 2.
That makes a lot of
You might need to check, make sure that the matrices are put right.
Are we supposed to enter
Yeah.
another one?
Well, you'll enter this as A, and then this one as B.
Oh, we're not entering the answer. We're.
Putting these two, and we can subtract them.
Oh. Okay, that's my bad. Hang on, let me restart.
You're good.
How do you restart this?
So second matrix, and then go over to edit. And then instead of staying at the top one at A, go down to B.
Our answer, this would be our answer. Still says matrix.
So if you notice next to matrix A, the second matrix over to edit. So if you notice that the black box is now at 2.
Oh. So you go to edit next.
Yep.
Yeah, I was struggling with that too.
Okay.
So 4 of y'all in here are in academics. Technically. So y'all know how to read this off for academics, right? Because again, left and right are our rows, yes? So technically for academics, the way they would want this is first row left to right, 3, -5. Second row left to right, -2, -4. Third row left to right, 3, 2. They would want you to specify each one, which is technically how you should do it, because otherwise you don't know what you're saying, but they're weird to pronounce.
So this is a 3 by 2.
Yes. So, we kind of get how this works, yes? For the most part, with just straight addition, subtraction, it's almost quicker to do it by hand than it is to type the thing in. Even if, once y'all get used to typing these in, it's still faster to just, especially here, -1 plus 6 is 5, 7 plus -4 is 5 plus -8 is, and 3 plus 2 is. And I mean, we could almost add and subtract them just as fast as it takes to plug it matrix A in, then matrix B, and then do A minus B or A plus B. Do we need to see another example of addition or subtraction? We feel good with this here, yes? All right. What's this one? Because it's a 2 by 1 and a 1 by 2. They're not the same.
Is this the second one?
You went to C.
But
So you got
it
the
was already used.
right. That's fine. Because I can go over, say, edit 3 by 2. You can write over the top of it, because we can just redefine A as many times as we want. So whenever you click the green button, the alpha button, all the buttons, what's written above each number or key in green is what it will do. Mhm. So the ones that are blue, the blue text above each button is second. Those. And so if you're graphing, so you can zoom in or zoom out. All right, guys, focus in here. Scalar multiplication is what we're going to do next. When working with matrices, a real number is often called a scalar. To multiply a matrix by a scalar, multiply each element in the matrix by said scalar. This is called scalar multiplication. So if we look at this here, guys, let's look at this one here. So we have 2 times the matrix. So we're using a scalar of 2, which means we're going to take all of our elements
And multiply them by 2.
and multiply them by 2. Yes. And we're going to just multiply it all by. So our 2 times 3 is 6. 2 times 1 is 2. 2 times 2 is 4. 2 times negative 2 is negative 4. 2 times 5 is 10. And 2 times 0 is. So we get this here. We'll get there in a second, because we have one more problem for sure that I want to go through, but it would be B, the first one on that page you're looking at. So do we feel comfortable with scalar multiplication? All right, let's look at scalar multiplication and addition subtraction. Let's do them both.
Work together at the same time.
Mm-hmm. So whenever we do this, the first thing we're going to do is the scalars. So we're going to multiply this first matrix by negative 3. So we'd have negative 3 times 5, negative 3 times 0, negative 3 times 2, and negative 3 times 4. So we'll finish doing that scalar multiplication. Negative 3 times 5 is negative 15. Negative 3 times 0 is
0.
negative 3 times 2
Negative 6.
is negative 6. And negative 3 times 4 is negative 12. And we're going to add to it. So our first one's going to be negative 15 plus 1. And then we'd have 0 plus 7. So we'd have negative 6 plus 3. Oh, this should have been negative 2, which would have made that positive 6. So it should have been positive 6 because negative 3 and negative 2. I dropped a negative. And if we add these together, negative 15 plus negative 1 is 0 plus 7 is 3 plus 6. 9. And lastly, negative 12 plus 2 is negative 10. Questions on this here? So, if we wanted to do this one in the calculator, the first thing we would need to do is take the calculator and plug both of the matrices in. So we'll go second matrix, over to edit, and matrix A. Now, both of these are 2 by 2s. So we'll have 5, 0, negative 2, 4 as the first matrix. And once you get that typed in, we'll go second quit, second matrix, over to edit, and then we'll go to B. B is also a 2 by 2. Negative 1, 7, 3, 7, 3, 2. Are we good with typing these in?
Yes.
If we had a third one we were working with, we could do A, B, C. Now, if we look at the problem, just so we can see how this looks, here we've defined this one as A and this one as, so we'll say that we're having negative 3 times A plus B. So guys, in the graphing calculator, the first thing we'll type is -3. And then we need to recall matrix A. So second matrix A plus second matrix B. And that does give us the same matrix. Now, for the most part, again, doing most of these by hand is a little bit quicker. But when we start getting multiple scalars or fractional scalars and different things here, it becomes more negligible on which one's faster. Sometimes it's faster if we have a lot of operations going on at once. But questions on this here? Are you ready for the next part?
Oh, homework.
4 through 8, 9 through 21 odd.